wires in it. One of them is this main wire here, and the other one is a wire on a loop, which is free to swing. The current comes in, goes down through this wire, comes out here, goes through a mercury cup so that it can get into the loop, comes around half of the loop, goes out, and back to the power supply. The loop is mounted in bearings, and then in addition, there is a wire suspension that holds the loop up so that the pressure on the bearings is not too great and provides the torque that allows it to swing back and forth and come back to the same position every time. There's a pointer which indicates the zero position of the loop, and a dial which we can look down on for a moment and see both the pointer and the dial. There's the dial. When I change it, now if I look at the loop at the same time, I can see what the effect of that will be on the... If I turn the dial away, it'll move the loop away. If I bring it back, it'll move the loop back. So one of the things to do is to center the loop very carefully. Actually, before one has done that, it was important that the device is level. One takes this and sets it up against here and against in this direction and use the leveling screws on the base. It's this post rather than the base that one wants to be sure is vertical. Once having done that and centered the loop, then one wants to adjust the spacing between the two wires. Since the current is going down in one and up in the other, there'll be a repulsion, and one can adjust the spacing by moving the wire back and forth both at the top and the bottom. And that one can do by setting it with this at the pointer. I'll set this now, let's say 1 centimeter between centers. And then I'll check that it's parallel. I'll move this over and see that it hits the rod both at the top and the bottom. It's actually not quite parallel. It hits at the bottom just a little sooner, so I'll move this over and fasten it up on the top here. And now the loop and the two wires are parallel and the spacing is uniform between them. And this is set at 0, or very nearly. Yes. And so I can take a reading on the dial when it's at 0, and then I can go turn on the current and measure the force between them. So let's look at the power supply and see what's involved in that. There's a knob which controls the current, and of course the switch, and then another switch which is in series with the current to the device. When I do that, I get about 18 amperes, and as I increase this, I can go up to 40 amperes. That current is limited by a resistor here and can't go any higher, but one can get a variation between about 20 and 40 amperes, or perhaps in some cases a little higher. So let me turn this off and then check that this is again at 0 and see what the effect is when I turn on the current. When I do that, see, I get a very definite deflection. It'll settle down at some distance. I was interested in the force at 1 centimeter distance, but now the distance has changed. So what I can do is twist the wire until it comes back. Let's look and see what happens as I do that. We'll look both at the loop here and at the dial at the same time. There's the dial, and now I'll turn this. It's at about 46 now, where it was set at 0, and I'll bring this back. I have to keep going till it gets there. Makes to make sure it's free, not sticking at all. A little more. And now it's right back where it was when the separation was 1 centimeter, and I have a deflection of about 12 millimeters on this dial. 12 hundredths of 180 degrees. So I can certainly get the relative force for different currents simply by measuring the relative deflection here. I can change the spacing again, but that won't give me the absolute force. How can I get that? Well, let me turn off the current, and we'll see. I'm going to turn this now so that the loop is free of the rod, and I can give it some oscillation. Now the loop is free, and I can give it some oscillation, and you see it has a definite period. By measuring its period and its moment of inertia, I can calculate what the torque constant of the spring is, of the suspension, and then in turn know how much a given angle theta in radians what torque that will produce, and since I know this distance, I can find out what force corresponds to that torque. To get the period, I simply time it with a stopwatch, but notice that it's very heavily damped, and therefore the measured period will not be the true period of the free motion, and that so I will also have to measure the damping. Let's see about what that is. It'll vary from one setup to another. I'll give it a deflection of 1 inch. And then it's about 3/8 of an inch after one period. Let's try that, do that a few times. Again, a deflection of about 1 inch. And again, about 3/8 of an inch after one period. So the damping is very heavy, and I'll have to use that damping constant in order to calculate the true period from the measured period. In order to calculate the moment of inertia, I'll have to know the shape of this and the dimensions and the masses. In order that you don't have to take it apart, the masses of the various parts of this loop are provided with the apparatus on a separate sheet of paper. So, having determined the force constant of the spring, then one can use the experiment, this apparatus, for the measurement of the force between these two wires and the force per unit length, if you know the length of this wire, for a variety of conditions. And that's all that's involved in this experiment. But it's a fundamental experiment because that really determines the value of the quantity mu0, which is involved in the electromagnetic phenomena.
Experiments in Physics with Dr. Frank Oppenheimer was produced in cooperation with University of Colorado Television. This is University of Colorado Television. Experiments in Physics with Dr. Frank Oppenheimer. A brief demonstration of the equipment used in the Library of Experiments in Physics, produced in cooperation with University of Colorado Television. Today's experiment
This experiment of the force between two wires carrying a current has, of course, two wires.